Hi everybody. I'm Timothy. Just call me Tim. I'm here on behalf of SICE Pty Ltd, and this is a bit of a unique experience for me because I've done a few of these before now, and usually when people ask me what SICE stands for, it's a room full of people that won't understand when I say Sociedade de Construcciones Eléctricas. That's fantastic. To start with, I'm just going to talk a little bit about who we are. There we go. We're a Spanish ITS organization. We're all over the world, but we're headquartered in Madrid, and we have offices, as I said, all over the world. Predominantly, we work in tunnel systems. We do a bit of stuff in rail, but I'm going to focus mostly on what we've been doing here in Australia. So we've been here in Australia since 2008. And for us, doing tunneling systems since 2014. We started small, as you'd expect when you arrive to a new country, and now we're dealing with WestConnex and the integrated control of WestConnex, which is arguably one of the most difficult tunnel integrations in the world. So this is a high-level picture of Sydney. And the various tunnels that run through Sydney. In the top left there, you can see in the green, the new M4. We implemented the control system for the new M4 that opened in 2019 and for the M8 in the bottom in blue in 2020. And these systems have what we call an OMCS, an Operations Management Control System. And what we're working on at the moment is that M4, M5 link in the middle that's planned to open in 2023. Now, that is going to have its own standalone OMCS as well. Each of these OMCS systems control each individual motorway, and that's a bit of a problem because when you've got cars flowing from one motorway directly into the next and they're not necessarily speaking to one another, of course, you can have all sorts of traffic incidents and things can go wrong. So since about 2016, we have been engaged with Transport for New South Wales to come up with a solution to that problem. And the solution to that problem is the IOMCS, the Integrated Operations Management and Control System. Now, whilst we're working on these 3 tunnels and integrating those, at this point in time, you can see on this map up the top, you've got Rozelle Interchange and the Western Harbour Tunnel. Down the bottom, you've got the M6, you've got Sydney Gateway on there as well. All of these are future tunnels that the IOMCS is being developed to manage the integrated operations of as well. And as these sorts of projects come up in the future, this is going to be a pretty standard product to be able to control multiple interconnected tunnels. This is a system architecture diagram. This is a high-level picture at the moment. And a look at the different systems we have in order to produce a product that's capable of controlling multiple concurrent motorways. Each of the grey boxes here represent the OMCSs I've been talking about. And as we move through the presentation, we'll see some of the detail that actually exists in some of these boxes. So as I mentioned a moment ago, this is designed to control 6. I've only represented 4 here. Honestly, when I was trying to put 6 on the page, I didn't think it was adding any value, so I stopped at 4. And each of these grey boxes will have about 1.5 million data points in it. So when we have these 6 motorways connected up to the IOMCS in the end, we're looking at about 9 million different data points. And the data flows between those 9 million data points need to be categorized effectively into 2 different buckets. Those are data flows that need to make their way to a motorway operator, and we require human input. Something like if there's a fire declared, generally people want a human involved just to make sure that the algorithms aren't going to cause a problem. But then we also have the other bucket, which is decision making that can go on without operator input. Okay, so just to introduce you to some of the systems and the system groupings for the data flowing through the system. The first is the plant management system. It's a logic-based system that runs all the safety critical components of the motorway and provides near real-time and real-time data to allow as close to real-time responses as we can reasonably get to, given that these are safety critical systems for the motorway. As these are safety critical systems, these have to be what is called SIL rated, which is safety integrity level rated, which basically just verifies that the data can get from one location to the next with a certain degree of accuracy. In this case, it's SIL 1, which off the top of my head is 99.9999% of the time the data has to be totally accurate. Next, we have the TMCS system, which is the tunnel control system, or the traffic management control system, rather. Very similar to the PMCS system, but it doesn't require that SIL rating. And it does have a more diverse range of protocols. And because it doesn't have to be safety rated, it's more of a near time and batch system. This includes things like closing the tunnel, vehicle detection, driver advisory signage, that sort of thing. And finally, we have the ITS system, primarily designed to give operators the maximum amount of information about what's going on in the tunnel as possible. But it also does provide some input into the algorithms that then facilitates automatic decision making as well. Now that ITS system has the broadest range of data in it, and that's everything from CCTV streams to phone calls, some automatic incident detection stuff, all sorts of stuff. So you can see here, just putting these in big data terms, the three V's, volume, variety, and velocity. You can see there the volume that we're actually processing per day isn't really all that big when you're talking about big data. But given the way the industry is going, we are really preparing and starting to think about how we can represent some of these things that we're doing in big data terms, because we all know that sooner or later we're going to have to be able to deal with it. All right. So this is what the system actually looks like when we break down the different systems and the subsystems. Don't worry too much about trying to take in all this slide. We're going to break it down into a couple of easier to manage bites as we keep going. The line thickness here is important. The thin lines are used to represent data that is generally made available to operators via the Sidera platform. That's our proprietary platform. And the thicker lines here are used to represent data flows that bypass the Sidera system. And the Sidera system is generally aware of those data flows, but given the complexity of the system and that some of these systems need to talk to one another to make decisions before actually presenting information or knowledge to an operator, we've had to connect those, so I thought it best to highlight them. All right, so breaking these down a little bit, I decided to start with the ITS system. This shows the various data paths just through the ITS system. There's about 120 terabytes of data that's stored from this system a day. And this includes control of things like CCTV systems, automatic incident detection, public address, radio rebroadcast, the operational radio systems, telephone systems, and we've got a nice big video wall in the control room as well that's controlled by this. Moving on to the TMCS system. This system includes overheight detection systems, tunnel closure systems, incident detection, driver advisory systems, and you'll note here that the data flow systems are a lot more simple than the previous slide. They're pretty linear in that you can see the subsystems down the bottom there. They pass through the yellow box that's titled TMCS access software. That flows up into the OMCS and subsequently up into the IOMCS. That's because this system is primarily designed to give the operator's interface to the devices at the roadside. That's true of everything in here except for the dotted line. And that dotted line is a unique data flow that we have specifically because if something goes wrong, let's say there's a fire in the main control center for the whole motorway, or if there's a bomb threat and people have to evacuate, you need an emergency means of closing the tunnel. And so the operators have a couple of buttons on their desk such that if they have to leave that room very quickly and the tunnel needs to be closed as a result, they can hit those buttons. The data flow then skips the usual path of going through the OMCS and using that safety rated system I was talking about before, it will go about automatically closing the tunnel. Okay, and this is the PMCS system, and this is where things get a little bit more interesting in terms of data flows. So this includes fire control, electrical control, hydraulics, lighting control, mechanical ventilation and air conditioning, and ventilation for the whole tunnel. So note for a moment the thick lines I've drawn between the PMCS systems for each of the tunnels here. These are to indicate the data flows that happen between the PMCS systems themselves that don't require operator intervention. In the case of ventilation, whilst operator intervention is possible to either increase or decrease the airflow through the tunnel, it's generally set up to operate itself, trusting that the algorithms that we have in place are more efficient, can make better decisions in a much shorter space of time than a person can, given the number of jet fans that we have in the tunnel. And it's a key example of how we're moving more and more away from having people controlling these complex systems and letting algorithms take control. And here, I kind of wanted to use this opportunity to put my finger on a bit of an emerging issue as the control of data and algorithms controlling more of our lives increases. So I've got a question for you here, and I want to get this a little bit interactive. So I'm going to ask this question. I'm going to put two options up on the screen, and once we've had a look at the options, I just want to take a show of hands for either A or B. All right. So I've taken a quote here from Yuval Noah Harari. He's the author of *Sapiens, Homo Deus* and 21 Lessons for the 21st Century. So I want you to imagine a driverless car heading down a road with its owner asleep in the back seat when two children suddenly shot out in front of it. We have two options. Should the car A, continue straight ahead and kill the children, or veer away from them only to collide with an oncoming truck that was sure to cause the death of the owner? Couple of notes here. Computers don't have a subconscious, right? It's going to do exactly what you program it to do. And from the car's calculations, these are the only two options available. All right. So I'm going to participate in this too. You'll see my hand go up. Let's see a show of hands. Should A, the car continue straight ahead and kill the children? Or B, veer away from them only to collide with an oncoming truck that was sure to cause the death of the owner? All right, now I think I'm going to make a couple of you that have answered B uncomfortable here. For those of you that answered B, would you buy the car knowing that in the prior scenario, your life would have been forfeited? All right. Couple of additional questions. When you buy a new car, should the car ask you, do you want to prioritize your life or other people's lives? And the last one, would you even consider prioritizing others in the previous question, knowing that most people won't do the same? All right, that's me. Any questions?
Thank you very much.
Try not to take everything with me.
Any more questions? Yeah.
I'm not sure you want me to decide. Okay.
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 A question, quick. We are ahead of time. Oscar.
Thank you very much. Very interesting. Just out of curiosity, everything that you explained was for panels like for cars?
Yes, that's right. Yes.
And do you do much with trains? You said at the beginning that some.
We do have rail control systems very similar to the product I was talking about today. I personally work in tunneling project management rather than the rail systems. So my answers to your questions about rail will be limited. But yes, we do have similar products that can control rail systems as well.
And I guess it's a bit more simple, that it's simpler than.
It's both simple and more complex. Trains need to know where other trains are and they need to interact with one another, but they don't need to interact with things like pedestrians or someone's not going to get off the train in the middle of the tunnel, whereas someone might get out of the car in the middle of the tunnel, and both have their unique difficult situations to deal with.
And this last question is very selfish. I live very close to Roselle interchange.
Okay.
Will it be underground, all the interchange?
Everything's underground except the portals, yes. Obviously, they need to come, except the portals, obviously they need to come above ground at some point to exit the tunnel. So there is going to be some impact around where they have to come above ground, but otherwise it is all underground, and it's a bit of a spaghetti network underground too. It's a really impressive tunneling job. Yeah, no, all underground.
And the tunnel that you show for the MC X6,
yep,
going to go for long south, or?
Yeah, so it joins, so where the current M8 tunnel joins the M4 M5 link that I was talking about. So in St. Peters, yes, it goes down south, and I think the exit's going to pop out somewhere near President Ave down there. Yeah, no worries.
Thank you very much.